So Coulomb's law allows us calculate the magnitude and direction of a force due to electrostatic interaction. So electric force can be attractive or repulsive. Let's analyze the case in which electric force is attractive. Electric force is attractive when we have two charges of opposite signs. So if Q1 is negative and Q2 is positive, then we're going to have an attractive force. And if Q1 is positive and Q2 is negative, we're going to have also an attractive force because opposite signs attract. So if we analyze this as a diagram, then imagine that we have two charges, right? A positive charge and a negative charge. If we go and focus on this positive charge, the force due to electrostatic interaction is going to be towards the negative charge. Also, if I go and I focus, my object of interest is going to be my negative charge, then the force due to electrostatic interaction is going to be towards my positive charge. Those two forces have equal magnitude, so I should check what is the size of my two vectors from here to here, from here to here, kind of a little bit less smaller. I think that's fair enough. And the magnitude of that force is going to be given by Fe, by KQ1, Q2 over the distance R12 square, where that distance is just the distance between my two charges, okay? These charges are stuck, which means they are not allowed to move, which means that this R12 is constant, okay? They are fixed at some distance. The charges feel a pull towards each other, but they do not move. And this is why this is electrostatics. Because my charges do not move. Okay? So that is the idea in which we have electrostatic attraction.